In this video, I want to have a look at theoretical probability. So using words like likely and unlikely isn't a very precise way to describe the probability of an event. So instead, we calculate the probability and write the answer as either a fraction, a decimal, or a percentage. So we can calculate the theoretical probability of an event, so in theory how often something's going to happen or the chance of something happening. Using the formula, the probability of that event is equal to the number of favourable outcomes, so the number of possible ways that event can occur, divided by the number of total outcomes, so the total number of things that could happen during our experiment. So if we have a look at a few examples, our first example says, if we flip a coin, what is the probability of flipping a head and a tail? So the probability, and we'll write probability of H to stand for head. Then we're going to have the probability of tossing a head would be 1, because there's only one head, and there's two possible outcomes when we flip a coin. We can either get a head or a tail. So we've got 1 out of 2. So the probability of flipping a tail would be the same. There's only one way that we can get a tail, and there's two possible outcomes from that experiment. So we've got a half and a half. We could say that there's a 50-50 chance. All right, our next one. If we roll a die, what is the probability of rolling, first off, is a 5. So if we roll a die, there's 6 possible outcomes that could happen. We could get a 1, a 2, a 3, a 4, 5, or a 6. So the probability of rolling a 5, so we'll write P of 5. Well, there's only one 5 on that die, so we'd have one favourable outcome over a total number of 6 outcomes. So the probability of rolling a 5 is 1 out of 6. Probability of rolling a 3 or a 4. So we'll write P, 3, or 4. Well, a 3, there's one 3 and there's one 4. So if we're rolling a 3 or a 4, then there's 2 possible outcomes that satisfy that. Out of a total, well, there's still 6 outcomes in total. So 2 out of 6, or we could simplify that fraction to 1 out of 3. Right, the next one is an odd number. So we'll write the probability of odd. So the odd numbers on a die, we've either got 1, 3, or 5. So there's 3 outcomes there out of a total of 6. So we'd have 3 over 6, or we could simplify that to a half. And our last one with this is, if we roll a die, what's the probability of rolling a number other than 2? So the probability, and I'm going to write the probability of not 2. So we want anything other than a 2. So there's 1, 2, and the other numbers are 1, 3, 4, 5, and 6. So there's 5 outcomes that are not a 2. So the probability of rolling a number other than 2 would be 5 out of 6. So we've just got one last example. So we've got this spinner here, and it says if you spin spinner A, what is the probability of it landing on red or not red? So you can see each of these sections on this spinner, they're the same size. So there's 3 equal sized pieces there. So the probability of getting red would be equal to 1 out of 3 in total. Then we've got the probability of it not being red. So there's new notation here. Instead of writing the word not red, like we wrote not 2 up here, we could have instead written a 2 with a little squiggle above it. So what we're going to write here is an R with a little squiggle above it, and that means not red. So we could have up here written P of a 2 with a squiggle above it, and that would have meant the same thing. So the probability of not being red, well, that means it can either be yellow or blue, so that's going to be 2 out of 3. So that's having a look at theoretical probability.